At 2:38 in the black waters of the English Channel, two massive steel hulls are converging on a collision course that threatens to dump 37,000 tons of naval displacement and hundreds of thousands of gallons of fuel into the world's busiest shipping lane. The Russian frigate Admiral Grigorovich, a 4,000-ton missile carrier, has just swung across the bow of the British replenishment ship RFA Tidespring, leaving less than 100 meters of clearance between them. If the helmsman on the British vessel flinches or delays by a single second, the kinetic energy of the impact will tear the hull open, creating an environmental disaster that would shut down the channel for months and cost the global economy billions. The tension on the bridges is absolute. One wrong turn creates a geopolitical firestorm that cannot be extinguished with diplomacy. The Russian captain maintains his course, betting his ship and his crew that the British will yield to the laws of tonnage. In the background, a silent, invisible network of sensors is watching, waiting to see if this gamble will end in crushed steel or a tactical retreat. Before we dive in, comment where you are watching from and click subscribe. This confrontation is not an isolated incident of aggressive seamanship. It is the physical manifestation of a breaking point in global sanctions enforcement. For months, a shadow fleet of aging tankers has been moving illicit oil to bypass the economic stranglehold on the Russian state, turning the English Channel into a critical artery for a war economy. The cost of letting this shipment pass is measured in the continued funding of a conflict that has claimed tens of thousands of lives, while the cost of stopping it involves risking the safety of civilian merchant traffic in a narrow strait used by 500 ships daily. The Royal Navy, stretched thin by decades of budget cuts, is no longer fighting a traditional battle for sea control but a desperate struggle for information dominance against an adversary willing to weaponize risk. The single decision by the Russian commander to cross the bow of a British vessel marks the moment when psychological intimidation escalated to the physical brink, permanently changing the rules of engagement in European waters. If the alliance blinks now, the precedent is set that territorial waters can be breached with impunity, rendering the blockade meaningless and handing a total strategic victory to the Russian fleet. The timeline of this engagement begins with the maneuver at 2:38, but the tactical reality was established long before the ships left port. To understand why a Russian commander would risk a hull-to-hull collision, we must reconstruct the operational picture starting from the water's surface. The Admiral Grigorovich is a Project 11356 frigate, a vessel designed specifically for anti-submarine warfare and long-range strike, armed with caliber cruise missiles capable of hitting targets hundreds of kilometers inland. However, on this night, its primary weapon is not its missile tubes, but its electronic warfare suite and its hull. The Russian vessel is not operating alone. It is the sharp tip of a convoy protecting two oil tankers attempting to slip through the maritime blockade. If you look at the radar tracks from that moment, you will see the Grigorovich pivot sharply to starboard, a move known in naval terminology as crossing the bow, which forces the opposing vessel to yield right of way or strike the aggressor amidships. This is calculated aggression. By placing a warship directly in the path of a slower, heavier support ship, the Russian commander is using the laws of the sea as a weapon. Banking on the Western reluctance to instigate a kinetic exchange, the British vessel, the RFA Tidespring, is a Tide-class fleet tanker, a massive 37,000-ton logistical beast designed to keep the Royal Navy running, not to win dogfights. When the Grigorovich cuts across its path, the Tidespring is forced into an emergency evasive turn, listing heavily as its rudder swings hard over to avoid impact. The physics of this moment are unforgiving. A ship that size does not turn on a dime, and the momentum carries it dangerously close to the limit of stability. For a few seconds, the outcome is suspended in the dark spray of the channel, The Russian captain achieves his immediate objective. He disrupts the flow of the interception and buys time for the tankers to make a run for the international zone. But this maneuver exposes the Grigorovich to a vulnerability it cannot armor against: the all-seeing eyes of a combined NATO surveillance network that had been tracking the task group since it slipped its moorings in the Baltic. At 2:45, the tactical standoff shifts from the physical to the digital realm. While the eyes of the world were on the near collision at the surface, the Russian fleet had already fallen into a digital trap set hours earlier. The Russian strategy relied on a sophisticated deception operation known as AIS spoofing. Think of AIS, or Automatic Identification System, as a transponder that shouts a ship's identity, speed, and location to everyone in the area. The Russians were manipulating this signal to create a Hall of Mirrors effect. By broadcasting false coordinates and identities from the Grigorovich and its escort vessels, they generated phantom contacts on civilian and military radar screens. 3 ships suddenly looked like 12, creating a matrix of ghosts, moving in interlaced patterns designed to paralyze the decision-making process of any force trying to intercept them. The goal was to hide the 2 oil tankers within this cloud of noise, and making it impossible for a commander to legally order a halt without risking the interception of a civilian merchant vessel. However, the Alliance response was a masterclass in multi-domain sensor fusion. To defeat the radar ghosts, NATO assets activated a technology called synthetic aperture radar, mounted on a Boeing P-8 Poseidon maritime patrol aircraft circling high above. Traditional radar works like a flashlight in the dark. It sends out a pulse and waits for an echo. But that echo can be fooled by decoys or masked by the clutter of waves. Synthetic aperture radar is different. It uses the motion of the aircraft to simulate a massive antenna, effectively taking a high-resolution photograph of the ocean surface using radio waves. If you look at the raw SAR data from that night, you see through the electronic fog. The metal hull of the Russian ships stands out starkly against the water, regardless of what their electronic transponders are screaming. The radar decoys deployed by the Russians, which simulate the radar cross-section of a warship, appear as hollow, unnatural blips lacking the physical density of a steel hull. While the P-8 painted the surface with electronic waves, another eye was watching from the stratosphere. The U.S. Navy's NMQ-4C Triton drone, a high-altitude, long-endurance surveillance asset, was using its infrared sensors to hunt for heat signatures. This is the Achilles heel of the Russian deception. A radar decoy can reflect a radio wave, but it cannot generate the massive thermal bloom of a gas turbine engine pushing a 4,000-ton frigate through the water by overlaying the SAR radar image, which sees shape, with the infrared map, which sees heat. The Link 16 data network instantly separated the real targets from the ghosts. The truth was revealed in seconds. The 12 contacts collapsed down to 3 real ships, the Grigorovich and 2 tankers. The Russian deception was not just defeated, it was used to pinpoint their exact location. By 2:52, the Russians realized their visual cover was blown and escalated the confrontation to the 3rd dimension, the air. From the heavily fortified exclave of Kaliningrad, 2 Russian Sukhoi Su-30SM flanker fighters scrambled to intercept the surveillance assets. These are formidable aircraft designed for air superiority with thrust vectoring engines that allow them to perform maneuvers that would rip other planes apart. The lead Su-30SM targeted a British Eurofighter Typhoon that had been scrambled from RAF Coningsby. To monitor the situation, the Russian pilot executed a maneuver that is as dangerous as it is aggressive. A high G-brake turn directly in front of the Typhoon's nose. By flying just meters in front of the British jet and engaging his afterburners, the Russian pilot attempted to blast the Typhoon with jet wash. the turbulent, high-velocity exhaust stream. The objective was aerodynamic, not explosive. By forcing the turbulent, high-energy air directly into the Typhoon's engine intake, he hoped to cause a compressor stall, a flame-out, or a catastrophic failure that would send the British jet plunging into the sea without firing a shot. This was a brute force tactic, a relic of Cold War intimidation. But the response from the British pilot demonstrated the technological chasm that now exists between the two forces. Instead of breaking away or engaging in a turning dogfight, the Typhoon pilot relied on digital superiority. He engaged the BAE System Striker 2 helmet-mounted display. This system effectively turns the pilot's head into a weapon sensor. Using eye-tracking technology, the aircraft's computer synchronizes the missile seeker directly to where the pilot is looking. Simultaneously, the Typhoon activated the Leonardo Captor E AESA radar. Unlike older radars that use a mechanically rotating dish, this is an electronically scanned array capable of focusing energy like a laser. The pilot switched the radar to burn-through mode, flooding the Su-30 with concentrated electromagnetic energy that overwhelmed the Russian fighters' L-175V jamming pods. The result was instant and decisive. Even as the Su-30SM pulled a 90-degree angle off the Typhoon's nose, a position that traditionally would have been a blind spot, the Striker 2 system projected a weapon lock directly onto the Russian jet's fuselage. Hanging from the Typhoon's wing was an MBDA Meteor missile. This is not a standard missile. It is a beyond visual range weapon powered by a ramjet engine. Think of a standard missile like a thrown rocket. It runs out of fuel quickly and coasts. The Meteor breathes air like a jet, allowing it to throttle up and accelerate towards the target, maintaining high energy all the way to the impact. This creates an inescapable zone 3 times larger than older missiles. Inside the Russian cockpit, the warning receiver screamed a continuous tone indicating a lock-on from an angle that physics suggested was impossible. The Russian pilot realized that his maneuvering had rendered him irrelevant. In a network-centric fight, the aircraft with the better data link kills first. He broke off the engagement and retreated, leaving the Typhoon in unchallenged control of the airspace. At 3:02, while the air battle fizzled out, a far more lethal game was playing out in the depths of the channel. The Russians had anticipated NATO surveillance and had deployed a submarine as an insurance policy. A Kilo-class diesel-electric submarine, known in naval circles as the Black Hole for its extreme quietness, had slipped its moorings at Baltijsk days prior. This submarine is a master of stealth, by running on battery power and using a single propeller designed to minimize cavitation, the bubbles that create noise. It can hide in the ambient sound of the ocean. Its mission was simple. If the surface ships were intercepted, the Kilo would be in a position to threaten the warships with torpedoes, forcing them to back off. To protect this asset, the submarine deployed a series of acoustic decoys. These devices, known as mobile submarine simulators, emit sounds that mimic the propeller noise of a U.S. Virginia-class attack submarine. The idea was to confuse the sonar operators on the NATO destroyers, tricking them into chasing phantom contacts while the real Kilo slipped into an attack position. But the Predator had become the prey. The U.S. Navy was already there, a U.S. Virginia-class fast attack submarine. In the namesake of the decoys the Russians were faking, had been trailing the Kilo silently for the past 48 hours. As the Russian sub launched its decoys, the Alliance launched a countermeasure that rendered the ruse useless. A Boeing P-8 Poseidon dropped a pattern of sonobuoys, floating sonar sensors, into the water around the suspected location. However, these were not standard passive buoys that just listen. They were part of a multi-static sonar network. Imagine a laser security grid in a museum. If you try to sneak through, you don't have to make a noise to be caught, you just have to break the beam. Multistatic sonar works the same way. The buoys emit sound pulses that bounce off the submarine's hull and are received by other buoys or the submarines nearby. The kilo, trying to be silent, it was actually casting a large shadow in the sound grid. By tracking how the sound pulses were interrupted and scattered, the NATO forces built a precise 3D image of the submarine. The Russian commander, seeing that he was boxed in by a network he couldn't detect, had no choice but to abort the mission. He ordered an emergency deep dive, fleeing the area at maximum speed, stripped of his stealth and his advantage. The hunter had been hunted without a torpedo being fired. By 3:15, the Russian task force was reeling. Their surface deception had failed. Their air intimidation had been countered, and their underwater threat had been exposed. Desperate and blinded, they turned to their final card, raw electronic power. The Admiral Grigorovich activated its internal electronic warfare system, the TK-255, coordinating with a Vishnya-class intelligence ship lurking nearby. Together they attempted to unleash an electromagnetic vice on the NATO fleet. Their goal was to sweep the frequency spectrum, flooding the airwaves with high-powered noise, to jam communications and radar links. They wanted to turn the English Channel into a digital blackout, severing the link between the NATO commanders and their assets. If successful, the alliance ships would be deaf, dumb, and blind, forced to break off pursuit to avoid a blue-on-blue friendly fire incident. But the alliance had anticipated this move and held its ace in the hole, the Boeing EA-18G Growler. This specialized electronic warfare aircraft is the most advanced jamming platform in the world. As the Russians ramped up their jamming, the Growler's ALQ-249 next-generation jammer went to work. What this system is not just a loud noisemaker, it is a cognitive computer capable of learning in real time. Within 3 minutes, the ALQ-249 had analyzed the Russian jamming pulses, identified their frequency hopping patterns, and cracked their digital signature. Then it did something the Russians did not expect. It launched a reverse hack. Instead of just blocking the Russian signal, the Growler used the Russian jamming beam itself as a carrier wave. It injected streams of corrupt data and false target information directly back into the Russian transmission. The Russian command screens, which should have been showing NATO ships scrambling in confusion, suddenly began to display phantom missiles and non-existent squadrons closing in on their own position. The climax of this electronic duel occurred at 3:25. With the Russian network thoroughly compromised and their sensors blinded by their own reversed jamming, the Growler delivered the final psychological blow. It transmitted a high-intensity, narrow-band signal directly into the combat direction systems of the Admiral Grigorovich. This signal was designed to trigger every missile warning sensor on the ship simultaneously. Inside the darkened combat information center of the Russian frigate, the night erupted in chaos. Every alarm blared, every screen flashed red. The radar operator saw dozens of incoming sea-skimming missiles. Seconds from impact, the Russian captain, paralyzed by the sensory overload and believing his ship was about to be destroyed, was faced with the ultimate dilemma. He could fire his defensive missiles and risk hitting civilian shipping, or he could brace for impact. And in reality, the sky was empty. There were no missiles. There was only the invisible crushing weight of NATO's information dominance. Amidst the blaring alarms, a simple text message was routed directly to the ship's communication terminal, bypassing all encryption. It read, "Hello, we see you very clearly even when you think you vanished." The psychological break was absolute. The Russian mission, already tactically defeated, now suffered a total collapse of will. The blinding whiteout of their sensors and the phantom threat of destruction forced them to shut down their offensive systems entirely. They pulled the plug on their jammers, turned their missiles off safe, and reduced speed. The resolution of this engagement was quiet and absolute. By dawn, the Russian state media was broadcasting stories of a heroic breakthrough past the Western blockade, spinning a narrative of victory for their domestic audience. But the mechanical reality on the water told a different story. The Admiral Grigorovich and the two oil tankers were no longer moving as a predatory wolf pack. They were shuffling forward at minimum speed, huddled together, escorted by the invisible perimeter of NATO sensors. Every mile they traveled was permitted only because the alliance allowed it. The US and British ships monitored their every move, from the turn of their screws to the heat of their stacks, herding them like prisoners out of the English Channel. The confrontation that began with a reckless physical cutoff ended with a total digital submission. No shots were fired, no steel was bent, but the outcome was decisive. The Russians learned that in the modern era, dominance is not measured by who has the biggest guns, but by who controls the electromagnetic spectrum. In these waters, you are not fighting a ship. You are fighting a network that sees you before you even leave port. The Russian fleet did not escape. They were processed,